Hi, we are going to look at section 7.5, which is about what strategy to take for integrating the given integral. Now, this is a table of integrals which you have seen before. It will be very useful if you learn all these formulas, because this, when we are solving an integral, most of the integral, they boil down to solving one of these integrals, basic integrals. So if you know them, it will be easy for you to think about the strategy you need to adopt. Some useful tips are that when you look at integral, the first and foremost thing that should come to your mind is, can I simplify this integrand? So inside the integral, the function can be simplified. Simplify means algebraic simplification, like canceling terms or using some trig identity or using some formula, algebraic formula. If you cannot simplify, then maybe try to classify your integrand as some specific form. Like, for example, if your integrand is a product of two functions, which cannot be simplified, so you can use integration by parts. If you have trig functions in there, just the trig functions, then you can maybe use some trig identity to simplify it, or multiply top and bottom by some quantity to get, to simplify things. If you have rational functions, then either use substitution might work, or you might have to do the integration using the rational partial fractions. Sometimes you can have just one term in the integrand, for example, just sine inverse x, or tangent inverse x, or ln of x. Then these can only be solved by integration by parts. And how? Well, in this case, you will have to take the given function here as your u, and the 1 as your dv, 1 dx as your dv. So you have seen these before. Let us see if I can do one of them later. So again, if nothing works, then you have to try again. Maybe you are not using the correct strategy, and so you might have to change your strategy and go on. But as you try more and more problems, it comes easy. It comes to you easy what to do on the next problem. So then here is an example. You have not seen something like this before. So we have the function integral of integral of square x times square root of 2 plus x to the 4 dx. Now if we had an x squared over here, if we had a square instead of the fourth power, we could have just set the in the quantity inside the radical as our u, and we could have done this problem easily by u substitution. But since we have x to the 4, it becomes a little bit complicated. So how do we tackle this problem? Now, we know this thing, that if we have a square plus x square, then we can do a trig substitution. The x is equal to a tangent theta. So if we have a square plus x square, we can do the tangent substitution. So that's what we are going to do. But before that, I will say let u equals x square. Then u square will be equal to x to the 4. Obvious. So this quantity will become u square. But now we have to do du. So du is equal to 2x dx. So dx will be equal to du over 2x. So now we come here and we substitute quantities. So we have integral x square root of 2 plus u squared times du over 2x. So now you see the x and the x get cancelled. So this x and this x at the top, they get cancelled, and we are left with integral square root of 2 plus u squared du with a 1/2 outside. So now this should look familiar. This will involve the trig substitution. So we now have let u equals square root of 2a tangent theta. So a is square root of 2, u is equal to square root of 2 tangent theta. So that du is tangent of theta, square root of 2 secant square theta theta. We will make our triangle here, which will come handy later. So what is the situation? We have theta somewhere, this one or the other one. So we call this theta. Then tangent of theta is x over 1, x over square root of 2, or u over square root of 2. Sorry. So that u is going to come on the opposite side because tangent is opposite over adjacent. So u will be here, and square root of 2 will be here, and then you can find this side. It will be u square plus square of square root of 2, which means 2 plus u squared. Okay, so this will come in handy later. Going back to our problem, we substitute back these quantities and we end up getting 1/2 integral square root of 2 plus u squared, so which means this quantity whole squared, which will give you 2 tangent square theta. And then we multiply by so we have square root of 2 secant square theta d theta, which is now equal to 1/2, actually square root of 2 over 2, I'm taking this out, integral of, so from inside here we end up getting square root of 2 into secant square theta and square root, which means secant, just secant theta, times secant square theta d theta. Now the square root 2 into square root 2 is 2. So 2 over 2 is 1. So we are left with integral of basically secant cube theta. So how do we now find out the integral of secant cube theta? Well, this boils down to finding the integral of secant theta in one way, because we can now write it as integral of secant theta into secant square theta, which is going back to this previous step. The secant square theta can be written as tangent square theta plus 1 d theta, which gives you integral of secant theta into tangent square theta d theta plus integral of just secant theta d theta. So now what to do? Now this term secant theta into tangent square theta, well, the derivative of secant theta is secant theta into tangent theta. So if we had secant theta into tangent theta over here, we know what the integral would be. If we had secant square theta into tangent theta, that would be easy. But now we have secant theta into tangent square theta, which is kind of, we have to think how to do that. Okay, so I will leave this here because basically we need to know how to figure out the integral of secant cube theta.